Semi-detached and end-of-terraced dwellings are easily designed using the foresight system. We input the details of the project. We will use the full-fill method of construction. It is attached, there's no flat roof, and the insulation is below the floor slab. Usually dwellings like this have timber joists. LCDs are no longer sufficient if the new fee standard is to be achieved. We need to use the robust or enhanced details. This project is a dormer that's following the profile of the ceiling, so this option is taken. The dwelling is end of terraced and has not got a basement and is not an apartment, so therefore all other dwellings is chosen. The user simply inputs the values and chooses the next part of the dwelling to be measured. The insulation and air barrier is following the profile of the ceiling on this particular project. We have more construction details. There are 3 exposed elevations on this particular project, which makes compliance a bit more difficult. The designer inputs the dimensions of the windows and doors, roof lights and hatches. On mid-sized dwellings like this, overheating is less of a problem than in smaller dwellings like apartments. We've collected the dimensions required by SAP and the thermal bridge calculator. Let's design the part L1A specification. Before we start into the design process, let us look at the thermal bridge. As you can see, it is approximately 0.05, which is the recommended Y factor when designing to the 2013 regulations. Let's go back to the first part of the specification to be designed, the floor. When designing a part L1A specification using the foresight system, the user chooses performance level to design to. In this case, the 2013 regulations. The designer chooses the structural materials, insulation materials, and the software works out the recommended depth of insulation. The U value is calculated to BR433 and is used by SAP to calculate the performance of the dwelling. The next section to be designed is the wall. The 2013 standard is chosen, the structural material and insulation material, and the software calculates the U value. For the flat ceiling design, the 2013 option is taken. The user chooses the centers of the joists, insulation between and over the joists, and the U value is automatically calculated. Because this is a dormer and the user has chosen to follow the profile of the ceiling, the sloping ceiling needs to be designed. We choose the performance level, centers, and the insulation material, and we click on save. The flat roof does not need to be designed on this particular project. It is locked and the user simply clicks on save and will be moved to the next part of the project to be designed. The windows. The designer chooses the 2013 standard. 2 choices will be presented. The designer should choose the 1.4 U value for the windows with semi-detached and end of terrace design. With the door, 1.0 U value should be taken. Roof lights do not need to be designed on this particular project. The thermal bridge is 0.05 and we have already discussed this. Air permeability. The user chooses the 2013 standard and the software will give 2 options. It is our advice that the designer chooses the 5 air exchanges. Ventilation. With the air tightness chosen, we can use natural ventilation. Lighting should always be 100% energy efficient. Stoves as a secondary heating source can be considered if the dwelling is non-compliant with the DER in the 2013 regulations. In most end of terraced and semi-detached dwellings, it will not be required if designing to the 2013 standard, but if designing to the fee or extreme fabric design, they should be considered. Solar panels as a secondary heating source can be considered if the dwelling is non-compliant with the DER in the 2013 regulations. Again, in most end of terrace dwellings, it will not be required if designing to the 2013 standard, but if designing to the fee or extreme fabric design, they should be considered. Hot water storage. If using a combination boiler or community heating system, then a tank does not need to be designed. If using all other direct heating sources, then a tank will need to be designed. The user inputs the number of occupants solar panels are being used, and the software calculates the size in litres. The depth of the factory fitted insulation is determined by the performance level chosen and is used by SAP. Water usage. Reduction in water usage helps with the code for sustainable homes. Boilers. All our boilers have an efficiency of at least 90%. We are using a gas condensing boiler on this particular project. Heat control is now becoming a very important part of Part L1A design, and we're using a delayed start thermostat and programmer and TVR. All the design decisions have been made. Now let's see if they are compliant with the 2013 regulations. Yes, we have compliance with both the DFE and the DER to the 2013 regulations. In most end of terrace and semi-detached dwellings, this will be the case. If there is non-compliance, it will normally be with the DER, and that can be resolved by introducing solar panels to the design. We provide design options for the fee standard and for the extreme or passive standard for end of terrace and semi-detached dwellings that are over 1200 square foot, because secondary heating systems such as stoves and solar panels can be introduced, and so can heat recovery systems, because they can work effectively in this size of dwelling. The introduction of the design options for fee and extreme fabric encourages designers to get more credits for the code for sustainable homes and design more energy efficient semi-detached and end of terrace dwellings.